Welcome back, dear students, to my YouTube channel and e-learning program of Gokhale Education Society. I am Pardesi AI, working as an assistant teacher in JDC Bitco English Medium High School, Nasik Road. Once again, I am here with the geography subject of Standard 8. Today, we are going to discuss chapter number 5, Ocean Currents. Currents. The term currents describes the motion of the ocean. Oceanic currents describes the movement of water from one location to another. Ocean currents are driven by wind, water, density differences and tides. An ocean current is a continuous directed movement of seawater generated by a number of forces acting upon the water, including wind, temperature, rotation of the earth, density, salinity differences and the gravitation of the moon. Currents are cohesive streams of seawater that circulate through the oceans. Now come to the page number 29. See the first point. Let's recall. See the questions in it. First one, when does any material flow? Second, what happens exactly when it flows? Third, which anomalies in the material is responsible for the initiations of the flow? When a material is too light and its shape is too big, it starts to flow. It changes its place or moves from one place to another. Most of the materials flow because its particles and molecules do not form a rigid and definite arrangement at a normal temperature and pressure. Now see the second activity. Try this. Materials required: a large metal tray, water, plastic sequins, spirit lamp, etc. Observe the figure 5.1. Keep the large metal tray on a stand, fill it with water. After the water becomes still, leave the sequins in them. After some time, the sequins will start floating in the water and become still too. Observe all these things. After some time, light the spirit lamp and place it below one corner of the tray. Observe what happens. See figure 5.1. On the basis of observation, discuss in the class and put forth your opinions regarding the experiment. Consider the following questions for the same. But due to the COVID-19, it is not possible to conduct this activity in the class. So just read the questions with me and we will discuss them. First question. What did you understand initially by observing the sequence? By observing the sequence, initially we understand that the sequence started floating in the water and become still. Second question. When the temperature of water started increasing, what changes did you see? When the temperature of water started increasing, the plastic sequence moved from one place to another. The density of water decreases as it becomes lighter. Therefore, the water having lower temperature, which was heavier, replaced the water with higher temperature. Third question. Observe the movement of the sequence. The sequence started moving in a circular motion. Next question. Question number 4. What conclusion can be drawn from the same? It can be concluded that there is a movement of sequence because of the flow of water. Question number 5. Where can such process take place on the Earth's surface? Such process can take place in the oceans. Next question. What are those processes and why do they happen? Those processes are called oceanic currents. They happen because of the difference in the temperature, density, planetary winds, Earth rotation and continental structure. Geographical explanation. It will occur to you that as the temperature of water increases, the plastic sequence moves from one place to another. As the temperature rises, the density of water decreases and it becomes lighter. And therefore the water having lower temperature which is heavier replaces the water with higher temperatures. After some time, the sequence starts moving in a circular motion. There is a movement of this sequence because of the flow of water. We should note that The source of the heat for oceans is the sun or sunlight. Our next activity is Can You Tell? A very strange incident occurred in the Pacific Ocean in the year 1992. A cargo ship sailed towards America from Hong Kong. While traveling through the Pacific Ocean near the Hawaii Island, a container full of toys fell into the ocean and broke. Around 28,000 rubber toys started floating on the ocean. This incident occurred on 10 January 1992. Now a strange thing happened. After around 10 months, on 16th November 1992, some of these toys reached the coast of Alaska. Some of them crossed at the Bering Strait and moved up to the Arctic Ocean by the year 2000. Observe the figure 5.2, map showing the distribution of the toys in the ocean, and figure number 5.3, a toy duck. Some of them also floated to Atlantic Ocean from the Arctic. Some of these reached the eastern coast of America in 2003, and some of the toys had even reached the European coast by 2007. From the Hawaii Islands, some toys took the route to Australia. Why did the toys travel in this way? The toys travel in this way because they were swept by currents and due to the differences in temperature, salinity, and the speed of the planetary winds. Geographical explanation. The ocean water can be divided into two parts based on depth: surface water and deep water. Surface water or the upper layer extends up to 500 meters from the sea level, and below 500 meter depth there is deep water. The region from sea level to the depth of 500 meter is considered to be the surface water. Sunlight can reach till this depth. The movements in this layer occur mainly due to the differences in temperature and salinity. The planetary winds give speed to the ocean currents. There are two types of the ocean currents. First, horizontal or surface ocean current, and second, deep ocean current. Let's we discuss the first type of the ocean current, that is horizontal or surface ocean current. The flow on the surface of the ocean moves only 10% of the oceanic water. The surface flow is considered up to 500 meters of depth. The discharge of water in the oceans is measured in Sverdrup unit. It is equivalent to 1 million cubic meter per second discharge. The horizontal flow of the ocean water occurs as warm and cold currents. These currents flow from the equator to the poles and from the poles to the equator. These currents are pushed to long distance by the planetary winds. As a result, the ocean waters flow from equator to both the poles and vice versa. Dear students, come to the page number 31, figure number 5.4, ocean currents. Make friends with maps, observe it carefully and answer the questions. In this map, two types of currents are given in an index. Red rays indicates warm currents and blue rays indicate cold currents. First question, what are the major types of ocean currents? The major types of ocean currents are warm ocean currents and cold ocean currents. Second question, what do you call the currents flowing from the equator to the poles? The currents flowing from the equator to the poles are called as warm ocean currents. Third question, what do you call the currents flowing from the poles to the equator? The currents flowing from the poles to the equators are called as cold ocean currents. Question number 4. When the currents are moving in a circular manner, what difference is visible in their direction in northern and southern hemisphere respectively? Answer. When the currents are moving in a circular manner, we see that currents flow in a clockwise direction in the northern hemisphere and in the anti-clockwise direction in the southern hemisphere. Clockwise means in the direction of the clock, anti-clockwise means opposite direction of the clock. Question number 5. What might happen at the places where these currents meet? Answer. Where these currents meet, plankton, vegetations, algae, etc., which is food for fish, might grow at that place. Thick fog might also be formed. Question number 6. When two different types of currents meet along the coast, then what type of human settlements and occupations are seen? Answer. When two different types of currents meet along the coast, linear settlements are seen and the occupation is fishing. Geographical explanation. We have studied that ocean currents are formed due to the differences in temperature, density and planetary winds. In addition, the following regions are also responsible for the direction of flow of ocean currents and their velocity. Rotation of the Earth. Because of the rotation of the Earth, the ocean currents move in clockwise direction in the northern hemisphere and in anticlockwise direction in the southern hemisphere. Continental structure. According to the alignment of the coastline, the direction of the ocean current changes. The velocity of the ocean currents is around 2 to 10 km per hour. The ocean currents are divided into two types, cold currents and warm currents.